Well, we are just a few minutes off the start time, so I understand if not everybody has had an opportunity to log in yet. But we're very thrilled with all the response this year. We've got 70 bridges that we're going to try to get to as many as we can in the time we have available to us this morning. There's a lot of hard work goes into these, and we appreciate the teachers and the students for putting the time and the effort in to make this happen. We can have Buster, but without bridges to bust, it's a very boring morning. We just sit there and look at a big red frame. So having 70 bridges to go, that's probably one of our best turnouts. We're still waiting on our 9:30 official start. We have had folks in. So what I'm going to do first off is announce the winners of our best looking bridge contest, our most innovative bridge contest, and our most promising bridge builder contest. We've had a couple of engineers come around the contest entries and review them in those categories, and we'll make that announcement before we start with the first bridge, which is already loaded on Buster, and I'm starting to get excited. I'm starting to vibrate. It's going to be great. And I would also like to, at this point, give a shout out to the volunteers that I have with me today. Don Hadley, Peter Dick, and Ponch Yogeswaran. They are helping me maintain social distance, and we keep this running smoothly. And to Mr. Walker, Randy Walker, who helped us get this video set up to roll this morning. And what we're going to have going on will be, we'll describe the bridges, we'll announce whose bridge is being tested. You'll get a live view like this. That's our first bridge up this morning. That is bridge number 6, Samantha from St. Michael's, and that's what we're going to start with. And in the bottom right corner of your screen, you'll see the output from our load cells. Those 2 silver S-shaped members, they capture the load as it's being applied to the bridge and output it to a display so that we'll be able to see in real time as the bridge gets loaded up. So people can keep track themselves. We're keeping track as well of the top 3 finishers, the load supported, and those folks who will coordinate with your schools for prizes at the end of our event. I don't have anyone in the waiting rooms, so we're going to get started with announcing the winners of the subjective results. For best looking bridge, the entry was Sasha from Quinte Public School. Congratulations, Sasha. Yay, everyone cheer for Sasha. Yay! The most innovative bridge design came from Ella Harris at St. Michael's. Congratulations, Ella. And our most promising bridge builder is Azam from St. Michael's as well. Congratulations, Azam. And as I said, we will be coordinating with your teachers to get prizes and trophies to you. So we'll flag the bridges as they come up when we see the most promising and the innovative and best looking bridges. When they get up on stage to have their moment in the spotlight, we'll just highlight that. Okay, so first up, bridge number 6, Samantha. Samantha, I hope you are ready to go. Gentlemen, start turning that crank. So let's see how it goes here. Taking up the slack in the cable. There we go. Load is being applied. Stop. There we go. Over a pound. 2. Oh, going way up. 43. Is it going to hold any more? Oh, starting to see some popsicle sticks. 43 6 pounds. So congratulations, Samantha. You are currently #1 on the leaderboard, 43.6 pounds. Well, the gentleman reset Buster and get ready for the next item. We will talk about bridges and what we have as far as the designs going on here. We've got got quite the range of styles. Some of them are going up quite high and some of them are staying reasonably low and flat. And we're on to bridge number 7, which is Margot from St. Michael's. Once again, we're taking up slack. Here we go. There's some load. And we're waiting. It's very, very tense, those first few pounds. And now it starts to jump. 7, I can hear a crack. 7 pounds, 7.0 pounds. Congratulations, Margot. That's a great start to the day. So you can see the 2 bridges that we've had have already failed in very different ways. One of them collapsed completely in the center, where another one sort of twisted and lost the pieces. And what we find year over year is that having the symmetry going inside the bridges will affect how much weight they can hold. Oh, well, folks, I've got hold for just one moment. I've got 2 classes that want to join in, but I need to send them a link. So please bear with me just one moment. Okay, so we just had a quick send out to a couple of classes who are going to be joining us shortly, but while we are waiting for them to go, we are going to carry on with bridge number 8. And I'm sorry, I know this is from Mr. Ross's class at St. Michael's, but we have unfortunately lost the name off this one. So Mr. Ross, if the member of your class who built this bridge, if you want to just send that to us in the chat box, we will add it to our list. This looks like a promising bridge, so go and crank away. Shivering like there's an earthquake. Did we build these bridges for earthquake? There we go. Load 3, 5, 6, 7. I'm not quite sure why, but our testers slow down as soon as the load starts to climb and the bridges start to buckle. So this one is separating from the whoa, 12.2. 12.2 pounds separated the trusses from the deck of the bridge. And there are ways that we can solve that issue when we're building bridges the next time around. Thank you, Sonia. We've got that name. When we're building our bridges, one of the ways is to make sure that your trusses, which are standing up, and the deck, which is flat, if the truss sits on the deck like this, it's very easy for that deck to start pulling away. When we see bridges where the truss is sitting vertically and then the deck comes and sits on top, there's a much improved distribution of load, and that's one of the ways that we can strengthen these bridges going forward. Just a moment. My goodness, my team here is on the ball, and they're going faster to reset the bridges than I can describe what's going on. So here we have Simon's bridge. Simon, here we go in 3, 2, 1. That load came on pretty quick. It's bouncing, which is, oh, 6.8 pounds, all the way to destruction. Sometimes when we have these events and we're hosting them live, we've always had a very different approach. Certain students really like to see their bridges go all the way. Others, as soon as that first crack happens, they're done. They're happy and they don't need any more input to the bridge. They're satisfied that they know how much it's going to hold. COVID's safe cough there. So we got bridges up and away we go. This is bridge number 10, Tessa D. A little bit more. I think it's got some more in it. 4.26. I'm not sure. Oh, right down through 4.6 pounds. We're up to a good start with these bridges. And I hope that when students are watching this, that you're taking an opportunity to look, and you'll be able to review these. All of the video for today is going to be posted to the NEM Ontario social feeds, as well as Quinte Professional Engineers and our YouTube channel. So we will have the opportunity to look back at the bridges afterward and see what happened as we carried on the testing and where things can be improved for next year. One of the ways that people do it is the way that they apply their glue, the way that they structure their bridges. So I'm looking at the next one coming up. This is bridge number 11. This is Max. And we can see a lovely triangular truss structure here. Lots of support going across to the different sides, and already up to 10 pounds, 12, 20, 50. It's It's going. It might have another bit. We've got popsicles flying. Everybody's wearing their safety glasses. Don't worry. I think that might be as much as this bridge is going to hold. 57.8 pounds. That's our new leader. 57.8. So Max, congratulations. You are on top of the world right now. And that's one where we can see those triangular structures in the trusses really help us keep moving. Now, one of the things I see on the bridge that we're loading up right now is Patrick's bridge. Nope. Move the supports later. So we're going to defer the bridge that we were about to load up. It is slightly under our minimum length, but never fear. Buster is adjustable. Buster will test just about everything. Okay, the bridge that was just tested. So, yeah, 57. That was Max. Yes, thank you, Mr. Ross. The next one up is going to be Deanna. And here we go, already up to 10 pounds. 12. Here are those little cracks as we go. And it slid off. So this is where we can review the 23.2 pounds as our top load there. When we're building our bridges, making sure that the two sides are symmetric, that they're made to the same plan, and that they are as parallel as we can get them. We see bridges, there are a few of them today that when we get there, we'll see that they have been very creatively designed, and it won't hold quite as much. It will take the load and it will distribute it in different directions. So we're trying to get that load to come as evenly as possible from the center of the bridge out to the two sides. So when we're building and designing bridges, as much as possible, making them even and balanced will improve their test results. And I'm about to get the thumbs up from the team here. All right, we'll get my associate out of there. There we go. And we're up to 6, 7, 8 pounds 9. So you can see that these even trusses. And now we're in a unique situation that where this bridge failed, it took the deck out. Peter, hold on. We have the opportunity in this case to see if we can increase the load that this bridge takes. So we have some bars that we're going to put across the deck and transmit that load to the two trusses. There's an opportunity here when we see that bridge deck just get torn out and the trusses have remained reasonably unaffected. There's still capacity in that bridge. And this is one of the moments that we really enjoy when we can see that there's an opportunity for more to be done with the bridge. So you got a great design and we've got an opportunity how we just improve it a little bit, which is taking that load and pushing it out to the sides, and then the sides take it and push it out to the ends. I think they're almost set up here. And no, don't reset. We're going to carry on from where we were to see how much more this bridge can see. We're already up another 5 to 10 pounds. So are we going to get any more out and before it breaks? 37 pounds. Has it got more? 40 pounds. So, way to go, Ruben. That was your bridge. And thank you so much for building one that gives us that opportunity to learn and see where those little changes can be made to just bring that load up a little higher. All right. Now that one, because it fell so far, is taking a couple of extra minutes to reset the machine. I will remind everybody that if you've got questions as we're going along, please type them into the chat box. And as we'll do our best to answer as we go. So this is another bridge that has quite a bit of symmetry going for it, as well as the triangular trusses. So we will see in just a moment, they're tightening up the nut to transfer the load. This one is just right on the edge of what meets our minimum 50 centimeter span. A little bit of load. I'm just going to hold it for just a little bit of way it moves on the support. Okay. And we are going to go live here. We're already up 25, 30 pounds, 40, 50. Ooh, oh boy. 124.6 pounds. So that one pulled through again, I'm being told. So we're going to put those steel bars in again and see if we can pull a little more weight out of that. But you see how close it was that it just tipped right off the edge of our support structure. Making the very minor engineering required and approved modifications to keep this going. Now, what I do? Everybody must just be breathless. We have no questions coming in through the chat box. Now, normally, this is obviously very different than the way we have been doing this for the past few years. We normally have a day when all the students can come and watch this in real time, in person, and turn the crank themselves to break the bridge. So the bridge that is up right now is Azam's from St. Michael's. And I've got like triple duty here. I'm talking to you folks, coordinating here and air traffic controlling. Let's see if Azam's bridge has anything left in it. So going to see if it breaks before that number changes, then it didn't, but hopefully we're going to see that number go up just a wee bit higher. A wee bit is an understatement. Now I think we've got the end of the bridge. That may be its ultimate load, 189.2. Well done, sir. So we're going to keep moving down the line. So I think that's probably one we very rarely have bridges where the popsicle sticks fly quite that far. That's why everyone who is at the opportunity, they have their safety glasses on just in case. But having popsicle sticks fly a good 6 feet, it really speaks to the amount of weight that that one was holding. So currently, we have Azam at 189, followed by Max at 57 and Samantha at 43. So we've got quite a few bridges that are holding some good weights. That's congratulations, folks. That really demonstrates how you are taking the structures lessons that you learn in class and applying them to actual construction. This is something that our civil and structural engineers and our mechanicals do on a regular basis, is take the design requirements, which in this case are, span that 50 centimeter gap, and you've only got so much material. It would be great if we could build everything out of the strongest and heaviest material, but we don't always have that option. So here we go with Reed's Bridge. Reed's Bridge is up to 28. And we have buckling of the structural supports down into the river. So 28.0 pounds. So these students, I don't know if the teachers can chime in here through the chat and just talk about what they discussed in class as far as the methods and the approach that they took to building their bridges. Some of the items that we have the opportunity to go into classes beforehand, and there are a couple things that we talk about consistently, are the application of the glue, whether you just put it on in great big globs and hope for the best, or if you spread it out nice and thin and evenly so that everything is held in place. One of the things that a lot of people are very surprised to learn is how the glue dries. The white glue that we ask folks to use has 2 times associated with it. One is the set time and one is the cure time, which we'll talk about after we finish testing Ella's bridge. There it is, ready to go, and the crank is turning. We have no clock. And away it goes. Sideways. 13.6. Yeah. So the bridges, sometimes it goes quite rapidly, and we are always surprised. We don't know which way the bridges are going to go when we start testing them. We get as much fun out of watching them as the students do, and hopefully as the students do building them. We were talking about glue just a moment ago, and glue has a set time of 1 hour. So after 1 hour, you can move that piece around and it's ready to move. But to get fully dry, it takes 24 hours. These ones have all been sitting for more than 24 hours. And now Tessa's bridge is up for test. And it's holding a little, there we go, over a pound, up to 5. Hey, 5.6 pounds. Excellent job. Now, I know we have one class that was not able to join us immediately off the jump first thing this morning. So a little bit of description of what's going to happen. Shortly, we're going to be transitioning to a class that can't join us for very long. But one student in that class decided to go for broke, try to beat Buster, and has built a 200 stick popsicle bridge. Most everyone today has stuck to the typical 100. At probably 10:15, we'll be transitioning and do a block of our 200 popsicle stick bridges. But for now, back to the 100s. We have Sophia's bridge, which is already up to 25 pounds. Had to time myself there. And maybe a little more. 27.8. Carrying on, I think we are just about at the end of Mr. Ross's class. And they're loading up. Okay. And the load starts again. 3, 4, 5, maybe 10. A little more. Oh, and there it goes, right in the center of the well, it's not quite an I-beam, 12.4 pounds. It's one that we haven't seen too much of. And I will put it out there. I will challenge folks who are participating this year to try and build an I-beam with popsicle sticks that we can test on Buster. So that's something for folks to think about for the coming contest, because we are going to hold this again next year. Hopefully, next year we'll be back to the way we've done it in the past, which is having everybody together, having that community and everybody being able to get a good close look at the bridges and update all their methods and their designs before they get started. And here we are, 3.8. Can we get it all the way to 4 maybe? Is it? No. We tried. 3.8 pounds for Caleb and Cohen. And the next bridge, 3.8. Next up will be Gabby and Chloe. We have your bridge going on right now. If anybody wants to try and get, if Gabby and Chloe are watching, if they want to give a guess as to how much weight they think their bridge is going to hold, normally while they're being set up, I get a chance to interview everybody who has built their bridge. But we are limited by what we can do right now. Now this one is giving our team just a bit of difficulty. Oh, Gabby and Chloe don't want to guess on the weight their bridge is going to hold. So let's see what we get. Oh dear. That one, I think the might have been a situation where just a little bit more glue was required to hold some of those trusses to the bridge deck. But that's one of the things that we do. We do these tests, we learn, and we get the opportunity to build it better again. Anybody who wants to, we have had students that they've become disappointed. They thought at one point that they weren't able to participate in the contest anymore because they had reached the end of grade 8. No way. we encourage everybody to join our bridge contest, and we've had classes, individuals, scout groups, youth groups, anybody who wants to. We will take anybody from, as long as you can prove that you're the one that put it together, poured the glue and stuck the sticks, we'll test your bridge. Speaking of testing bridges, here we are, 4 pounds coming on to Jaden's bridge right now, up to 7.8, and it's gone into the drink. Well, I'm getting a chuckle because I like to imagine that all these bridges are being built one after another down a canal. So that's about the only place where you're going to find 2 straight lines consistently. Again, air traffic controlling. There's a lot of moving parts here, but the team here, they've been doing it for several years and they are professionals. Madison and Kate, you will see your names and your bridge and how much load it will take. Slow and steady, it seems, is the way that we're going to start this one. 2.2. Now we are moving up. Number 1 bridge. This is the first bridge that got dropped off to us. And number 1 bridge is Lennox. Thank you for waiting, Mrs. Durkin. So Mrs. Durkin's class. Oh dear. So hold that one up. I'm going to switch over the camera here. Don, if you can step to one side and lift the bridge just a bit, a little higher. Hey, there we go. We'll see that right there in the center, we had a structural failure just as that bridge started getting the load from the weight. So unfortunately, that one didn't hold very much. So we'll reset.
This one has a prize winner.
Oh, gentlemen. All right. Number 2, Dawson, Mir, Kira, Nakia, and Ella. Here is your bridge. Here comes the load. And the numbers say something. There we go. Oh, we've got a pound. 1.6. And that had the same style of structural failure as the previous bridge. So looking at these ones, a lot of what we see are popsicle sticks that are layered flat, one on top of the other, where we find popsicle sticks that are put up on their edge and glued that way. They have greater resistance when they're placed in bending. And we'll see that actually on the next bridge up, which has several sticks that are positioned along in that line. A couple of the things that the takeaways from building the popsicle stick bridges is we know that they have to span 50 centimeters, so they've got to go just a little bit longer. Oh dear. And I'm sorry to report that we've had another failure on the same one. Joe, if you can hand that bridge to me while you're loading up the next one. Yep. So let's do a little bit of forensic bridge work. Let's look right up here in the center, because this is where we had the failure. And at that point, the bridge is being held together. I orient myself to the camera here with some glue joints. I'm still here. So those glue joints, rather than having at the bottom here, having a piece that would bridge between those two spots will help us and carry that load when we're moving the bridge across. So we're up. We're going to try the next bridge. We'll see how we go here. It's up, it's ready, and we're up to 2 pounds already. This is Bailey and Sydney. And we're up to 9, I think 10, yes. 11, can we get to 11? Almost there. All right, though, whoa. That's a failure. That is the kind of failure that makes everybody jump a little bit when it goes off. We love those. Sorry, a little bit of glee. One of the other bridges has suffered a similar failure to this one when we picked it up to start to load, so we won't be able to test that one, which means we're going to take a slight break from our regularly scheduled structure to 200 stick popsicle bridges. So our standard contest is 100 popsicle sticks, white school glue, 50 centimeters to span. But a few years ago, we were so confident in the ability of our machine, designed by John Ireland in Upper Canada, that we said, we don't think anybody can beat it. So 200 popsicle sticks, use whatever glue you want, and see if you can beat Buster. And this one is going to try. Now this is bridge number 70. This is Ella, and this is the one that won the award for most innovative design. We're already up to 3 pounds. A little more. Come on, Coates. Come on, 10. Come on, 10. We can make it. I believe. It's got a very organic collapse to it. But I don't think we're going to go 8.4 pounds for our first 200 popsicle stick bridge. So, Quinte Public School, I hope you are online and ready to go. We've got your hot glued bridges here, and we are going to start. So we're going to take and finish off our specialized class here. So now, as it stands, no one has beaten Buster yet. We have had a student one time with 200 popsicle sticks. They were able to achieve over 600 pounds, but no one has broken the 1,000-pound mark yet. Will this be the year? I don't know. These are some good-looking bridges. It's obvious that the teachers and students have put a lot of care into these. And we're going to start with Karen and Leland. Your bridge is up and away we go, 25, 30. We can see that the bottom is starting to give a little bit. 75, 100. Keep having little bounces in here as one part of the bridge will take over from another. 125, 127. I don't know that there's much more in it, but we're gonna go until total structural failure. I tell you, the fellow on the crank today, he is enthusiastic. We love enthusiasm. He's making up for not having students in the room. So that's a good start to our 200 open class bridges. So 127.8 pounds on that bridge. If you guys can hand that one over to me, we can have a forensic look. Oh, nope, that one's going off to the side while we get the next one into the queue. So 63. So we've got Noah and Ronan. Noah and Braden. Thank you. So I've been handed our first hot glue bridge here, and we're going to have a look and see. So got quite the glue. Oh, I'm getting the thumbs up. We're ready. Put this away. Okay, and away we go on the next bridge. Noah and Braden, 4 pounds, 4.2. The sides are coming together and coming down. It's a beautiful smile. Thank you for making us smile today with your bridge. 5 pounds. So that is one that, we'll hold this one up as an example of bracing across the top. This one, although you can see quite clearly the failures of the pieces in here. So that's what snapped and gave way. But look at from end to end, how we've got braces going from side to side. That gives your bridge an extra rigidity than if we had stopped with just the trusses along the side. So it helps the bridge keep its shape until we put too much strength in the middle and we make a brand new shape. So this is one as well. Let me see. Aha, there it is. See if we can show that on the camera. That right there, it doesn't show up too much for contrast, but it did actually, it wasn't a glue joint that failed. It was the popsicle sticks. Now we're moving on to the next bridge, already up to 10 pounds. 23. I don't know where the happy and the glee went. This one's gonna take its load up a little slowly. This is Caitlin and Lynn's bridge. Big jump there. Oh, and I'm hearing snap, crackle, and fail. Snap, crackle, fail. 78.6 pounds to keep that one in the running as one of the stronger on our 200 bridge, our 200 stick class. I'm still, I'll again remind everybody that if you've got questions, feel free to type them into the chat box as we go along so that we can answer anything. If you have a question, if your bridge was the one that just got tested, raise a hand or type in a question and we will do our best to answer them as we go. This was a prize-winning bridge as well. So before we test it all the way to the end, folks, this is this year's bridge just judged to be the best looking bridge in the field today. All right, away we go. Let's see if best looking will also equate with most load on 200 popsicle sticks and hot glue. So we're up 30 pounds. That's a good start. Oh, 50 pounds. But I think I'm seeing the same as all my colleagues here, that bridging that one with some steel rods might just allow us to put that load a little higher. So we're going to take a moment. We want to know everything your bridge can do. We've got some people enjoying. Thank you, Mr. Blakely's class, for joining us and for having fun. Oh, I can't. We're not Canadians. We're Canadians. We're going to make it work. Okay, they're recentering it. All right, here it goes. So we're going to wait and see if that 50 goes up any higher. I'll hold my breath. What'll it do? There's got to be some more in there. Or it will slide off the side. Oh, nope. I think it popped up just another 0.1 of a pound. So 50.1, 50.2 pounds. Way to go. And congratulations on that bridge. That is our best looking bridge in the one of our structural engineers is reviewing the assembly and saying, well, that's still a good joint, that's still a good joint, that's still a good joint. We learn as much from when something goes wrong as when something goes right. Sometimes we learn even a little bit more. So every time we see these bridges and we think we've seen it all and we know what's going to happen, we get surprised. And we appreciate all the work that everyone is putting in to make this happen today. So Bryce and Shoshone, you're having your bridge loaded as we speak. And as soon as the camera field is clear, away we go. 8, 10 already, and it doesn't look like it's barely moved up, settling. Some separation at 30 pounds, but oh, look at the curves in that. That would be a fun one to drive across. 32.8. I don't know. That might be as much as it's got. It's got a nice big fold in the middle there. 32.8 pounds. Uh-oh. We had someone with a brief hand bridge coordination issue that resulted in not being able to extricate themselves from the bridge. So, oh my goodness. Wait till you see what's coming up next, folks. Oh. Olivia and Kylie got, oh, they're they're being thorough and investigative to make sure they can get the interaction between Buster and the Buster and the bridge. All right. This one might take try. So this bridge is going to require a slight modification so that there's enough room to get the bolt up through the bridge deck. And this is one of the items that we identify in the set of criteria for people who are building the bridge. And for students, we typically say, we want you to leave a hole in the center of your bridge for the pin that's about as large as a grown-up's thumb. Now we know not everybody's thumb is the same size, but most grown-ups, if they can get their thumb through that hole in the middle, we know that it's left enough room for us to put the pin in and connect everything. So rod is in, the plate is on, the display is zeroed. And the testing begins. It's a beefy design. Know that it's gonna, okay, we're up to 25 and it barely moved, 50 pounds. See a little bit of shifting, 64. Get to 65, I think there's 65 pounds. There, oh, 80, 100, crack 3 digits, 135, one side is going. I don't think it's gonna get any more. We're just gonna see if we can, no. I think even if we kept turning, that's not going to actually fall into anything, but 146.6 pounds for Olivia and Kelly. Congratulations, you two. That is one strong bridge. Yep, still have a couple of bridges left in our open division, and then we will get back to our standard configuration. I'd like to thank everyone who is logging in here today from the school boards and the observers. We've had a couple of people join us who I think are going to look at hosting, and I encourage them to reach out to me after the event to discuss how we put this all together and all the behind the scenes work. And there is a fair amount of behind the scenes work done by the folks who bring this together every year. All right, I'm getting a thumbs up, and we're going to test Daniel and Riley's bridge. Uh-oh. We've got a separation of the truss structure here as well as the bridge deck. So that has gone for a twofold failure into the water. Yes, water. I know there's no actual river or boats underneath, but we think about these things because we're hoping that some of these students, hope as you're watching, you're getting ideas, and when you go and drive around and you take a bridge over the train tracks or a bridge across the river, that you take a moment to look and see all of the elements that come together, whether it's the beams in the center of the bridge or the way that the decking is constructed or the loads at the end. It all comes together for successful bridges like this one from Paige and Ruby. Right, 65 pounds already. And jumping again to set, oh, we got separation of a truss, and folding of the bridge deck. All right. Yes. All right, so that was the end of our 100, or our 200 stick open class. So we're going back to the 100 sticks and white glue, and we are with Gavin and Braden from St. Mary's. So St. Mary's, I hope everybody is online and paying attention, because here we go. Ooh, we've got a loss at the deck. And that was again, we saw the situation where sticks layered flat like this pull apart very quickly, where the ones that hold like this and are sandwiched. So if you can get 2 or 3 sticks all stacked up together, it gives us the opportunity to have things keep together as they go. This one is going to get a slight assist from our bars to transfer the load. So we're just waiting for team. Sorry, yeah. Okay. All right. So here we have 5.6 G. And sorry, yeah, that was Gavin and Baden. 7.4. 7.4 pounds. 27. So we'll adjust here. 7. So our next bridge up is Joseph and Zach. Our bridge is in, our display is ready, and the testing happens again. So this one is seeing again a slope at the deck, 2.2 pounds. If you can hand that one to me, please, gentlemen. So let's have a quick look at this bridge. What we've got is we've got a good set of trusses starting here. And as we get across, we lose our truss structure here. And that is exactly where it failed. And it failed, we can see some broken popsicle sticks down here. And if we have the opportunity to keep these trusses going all the way to the far end of the bridge, it gives a, you bet. So we've got, Quinte is signing off for today, but they are requesting that Punch get in front of the camera and just give everybody a wave. Punch. Wave at the camera, sir. There we go. Thank you, Quinte, for being with us today, and we hope you had a lot of fun. We will be talking to you next time around. And we're moving on to bridge number 28, which is Charlie and Max. And it's That bridge deck is done. 0.4 pounds. Clink, clank, clunk. Well, you'd think we were doing some heavy structural work here with the amount of bangs and crashes we've got going on. So we're doing very well as far as getting everybody tested. We're at about the halfway of our time slot, and we're at about the halfway point of the bridges that we have available to us today. Next up are Elia and Kurgan. And we've got a bridge that is up and a display that is zeroed. So we have a test to go forward. Now, this is one where it's a little hidden behind the, oh, there we go. I don't know, 5. I don't think there's much. We're looking for it to slip off that last corner. 5.2 pounds. And this is one where we can talk about the symmetry of bridges again. That one had, where the bridge previous to it had trusses that only reached partway across. This one had one truss that went the full length and one truss that went 3/4 of the length. So it twisted and buckled in that one corner where the load didn't make it all the way from one side to the other. So this is when you're building your bridge, one of the things that we engineers try to do before anything gets done is to say that we plan the bridges, that we're going to figure out how large all the steel beams are and what the arch on the bridge is going to be, and to make sure that we've got enough material for both sides. Now this one is a triangular truss symmetric bridge already holding 9 pounds, built by Isabel and Monica. And we're up to 27. Is there any more in it? I don't think so. Isabel and Monica, great job. And your triangles really did a good job distributing that load from one end to the other and keeping it from just failing at one point. That one actually had, I think I saw 2 different points of failure on that one. So we're having an engineering consultation to load the next one up. And that is something we do. We engineers do consult with each other. Engineering is a team sport. All right, got it on. Got it lifted. All right, there's no slag. It's a precision operation getting these things in place. All right, all hands are off. And we're ready to test Talon and Taden's. Oh, someone has returned. Test is good. Away we go. 1.6235. Come on, 10. Yep. 20. 20. Do I see 25? 30. 36. Come on. Is there more? No, there is no more. That was an impressive one, folks. Thank you for your efforts on that. That was a great one to see put up on Buster. So I just got my team making sure that we keep rolling forward in a nice manner. Trinity and Alexandra, Alexander at St. Mary's School. So good morning to all the folks at St. Mary's. And got our steel supports in again. Balancing the bridge very carefully. Oh, this one is a delicate installation. So let's see how it goes. Come on, let's get her up to 5 pounds. There it is, 10. I was gonna ask for 10, but today it's 8.8. That was one where we saw the separation again of that deck at the bottom and the truss, and just pieces pulling away, where if you're able to slot them together in a way that really increases the ability of those pieces to hold together. Because you've got on your truss, everything is standing up straight and parallel. Oh boy. Rapid change here for Brianna and Layla. And we are up to 1 and a bit. And it's found a second support. 3 and a bit. Come on, 4. Not quite 4. Good job. Yes. Just doing a note check there. All of our contest winners have already been tested. So we're moving right along and coming through the crew here at St. Mary's. Got a few bridges still down there at the end of the table. All right, and this is Molly's bridge at 3.8, 3.6, 3.8. Look, we made it. A little more. No. 3.8 pounds, Molly. Good job. All right, we've got the pieces are going in to get it assembled for Haley and Maddie's bridge. And this is all from the St. Mary's class. Got it set up. We've got a nice set of, oh, last minute adjustment, triangular trusses, and away we go. This has got our distribution all the way to both ends, 6 pounds. Take it up, can we get to 7? What do you think, 7? Oh, sticks flying. And that's the end of that one. So we can see that even when we've got everything lined up, sometimes there is just a failure of the materials themselves. When students are, or anyone is building their bridges out of popsicle sticks, one aspect we encourage is review your materials before you get started. Popsicle sticks are great for popsicles. They are less great for building bridges. I can't remember the last time that I took a train over a popsicle bridge or drove over a popsicle bridge in my car. It just doesn't happen. So what can we do to make sure that we get the best results possible? Well, one of them is to look at our sticks and make sure that the ones that we choose for our bridges are straight and uncracked before we get started. Dylan and Peyton, here is your bridge already loaded up to 8, 9, 10 pounds and pieces flying. Lots of pieces flying. Whole sides of the bridge have gone and it's down in the middle. So having a review of your popsicle sticks as you're building your bridge. Yes, you can buy a package and it says 100 popsicle sticks. Well, what happens if 10 of your popsicle sticks already have flaws in them before you even get started? Well, you're hurting your own chances. So when you're building, check those popsicle sticks. Make sure they're nice and straight. Make sure that they are not cracked. Make sure they're all pretty close to the same length. Bonus points if someone can sign on to the chat and tell me what the dimensions of a popsicle stick are. I regret to inform you that we have had a critical failure of bridge number 37, Kian and Evan, before it even took its first pound of pressure. It had a failure, the same one that we've seen before, where sticks were coming just together like this and they were gone. So sorry, that was a 0 pound bridge this time around. And we are moving on to Evan and Preston's bridge, getting it loaded up into Buster right now. Okay, it is up there. Evan and Preston, here comes your bridge. And it did not hold to a level to register. What happened there, again, we had 2 sections of truss, but they came this close rather than joining right up in the middle. So keeping that continuity of structure throughout the bridge is going to improve your chances and get that load all the way from the center, to the outside edges. Got another one that's getting positioned and it is not holding. So we won't be able to test Ainsley and Evelyn's bridge today. It collapsed on being loaded up from both ends. Sorry, folks, but sometimes it happens. So we gotta getting this one, next one set up. We are working on getting 39 just collapsed. This is 40th. I get it. Okay, so number 40, ready to go, and already sitting at 6 pounds, 8, 10. Good job. 13. Samantha, sorry, Lilia McKenzie, 13.6 pounds. Good job. And that was, I believe, is this the last of, oh, okay. We have a bridge that is too short. So what we will do is we're going to defer that to the end. We will make an adjustment to Buster when all is said and done. We'll bring those ones in. They won't be eligible for the prime contest, but we will test them. Now we are on to Ms. Vanderlack's class. And we have a bridge sliding in and not holding very much. Okay, if I can get that one over here, please. Thank you. So, Curtis, your bridge here. We've got a nice buildup in the center of supporting structure right where our block goes. But off to the sides, this is where we would hope to see some vertical pieces that will give it some extra rigidity and away from smiles. All right, test the next one, which is Cabot's Bridge. And we're trying, it's moving, it's sliding, it's smiling, and it slipped off the edge. So that one didn't hold any weight to register with the load cells on our machine today. Up next is Miles and Rylan. And we're loaded up, ready to test. See if it's, no. We hear the snaps, but it doesn't take any and distribute anything to the side. It just started to fold in the middle quite rapidly. So we encourage people, when you have bridges of this style, to take some of these popsicle sticks along the bottom and repurpose them. We've got a lot of sticks here that aren't contributing to the weight holding. We can move them up here, even if we don't build a tall truss assembly. Even just making that switch of taking a few sticks off the bottom and putting them up on their edge will help move that load and increase the rigidity of your bridge. And here's one that has some sides to it. This is Warren and Liddy. We're almost, oh, can we get 15 pounds maybe? No, but 14 and an impressive deconstruction there. And that is Ms. Vanderlack's class. Thank you very much. You had some fantastic bridges in here today. I hope you had an opportunity to learn. The next batch all came to us from Our Lady of Fatima. Sorry, I don't have your teacher's name right off at the tip of my tongue, but I know that the first bridge is from Kira, Sophia, and Kerrigan. So here we go. We're going to see maybe a little more, maybe something. It's down. So I'm going to get this one back and we're going to do a quick discussion because we saw that it was holding itself up fairly well before when the testing started. And that's not the other way. But what we have are incomplete trusses. Taking, again, from our multitude of sticks across the bottom here and putting a link between the two elements here will give us that strength so that when it starts to go, these pieces are being pushed together and held apart by that extra popsicle stick in between. Now we have the next bridge on the buster ready to go and it's getting tested. This is Maddie's bridge. And it looks like Maddie's bridge is doing the same here where just those sides would benefit from where you bring back my visual aid, where you've got your triangles here, just bridging between those two triangles will give that added bit of strength when we're testing. Our next bridge up is Rihanna's bridge from Our Lady of Fatima as well. It is loaded and let's see what it does. Oh, so we're having a very consistent pattern with these last couple of bridges, and they were all built to a very similar plan. One thing I'll point out, that one started to fail with pieces going to the side like that. So there's a couple of different directions that your bridge is going to go when it goes to failure. It can go and snap in the center. It can snap sliding this way, or it can just fold up. To help it stay upright, once you've got the link between triangles like this, hey, look at that, triangles of triangles. If you've got your two sides, building on your two sides with a cross brace will help prevent things from wanting to tip side to side. Our next bridge, constructed by Kenzie and Paige, is being tested. 4, 6, 8, 10 pounds, 11, 12, a little bit of jump and flex, 15, jump and flex, and that's the end of that one. Good job, group. 15.4 pounds. We have a couple of bridges still to go from Our Lady of Fatima, and we are on track. We are on track to, in our 2-hour time limit, we're going to hit 70 bridges tested. I am going to take an opportunity right there while this bridge is being put together to shout out to the crew that is working here and getting the bridges up and tested. They're doing a fantastic job. And with, this is not a one-person or two-person show. You can do it, but many hands make light work, and having a good team on our side is doing wonders. So here we have Ben, oh my heavens, I looked away for a second and all of a sudden it was gone. 6.8 pounds for Ben, Evan, Ryder, and Owen. Wow. Sometimes it's just that fast. Other times you get to watch bridges like the Tacoma Narrows, and I encourage all the educators to show their students video that you can find on YouTube of the Tacoma Narrows Bridge. It's a lot of fun to watch, and it makes you think twice about how strong our construction elements are. But when you see a bridge doing a flop like this, oh, Mr. Ross's class, thank you very much for joining us. We've had a great time, and we will be in touch with some prize details. Yes, so Tacoma Narrows. Tacoma Narrows is when a bridge is flopping like this. Bridges aren't supposed to do that. They're supposed to be structurally rigid. And as we test Lily and Mackenzie's bridge, we're looking for that structure and it has pulled apart. These guys are having some fun here, making sure that everything happens. So this was, we're seeing bridges where the failure on that one was the glue joints letting go when they were being pulled apart that way. Okay. So we are AG, Jesse. Here is your bridge. And I think that one has gone down. So once again, the flat platform is doing its thing. This is, I believe, yeah, this might be our last one from Our Lady of Fatima. This is Faith's Bridge getting loaded up right now. Very careful assembly here. Getting its fine tuning. And away we go with our test. Looking for some resistance. Looking for some load and not finding it this time. But the elements are there to start. Okay, so thank you to the folks from Our Lady of Fatima. Those are your bridges. And we're moving on to a set of bridges that have come to us all the way from Amherst View. So these ones were late entries, but we still got them in time that we are able to give them a test. These ones are of a slightly different design, and we'll see how they perform. So this is the first one, arching in the opposite direction of what we usually see. But down it goes. That was Elena and Ryder. Okay. So we have another one. No, this one we have, oh, it's already had a critical failure before coming together. Hand that one over here, please. Oh, well, I'm getting a signal from the test pit that we're going to try it. We're going to see how it goes. Here we go. This is that correct, Lady and Ryder? That was Alana and Ryder's bridge. Yep. 0. Excuse me. Olivia, Tatiana, and Jesse. We're going to put your bridge up next.
56 doesn't mean the span requirement.
Oh, 56 is not wide enough, so we're going to defer it for a few moments. And we're going to move on to 57, which is Braylon and Kira. Oh, Braylon and Kira are just balanced. This this might go down very quickly. Yeah, slid through. So this is these ones that that one that slid through and the other one that didn't quite make the length requirement. We will make an adjustment to the busting platform and see how much load your bridge will take, even if it's over a slightly reduced span. And another one in the same category. Yeah. Yeah, that one we just. Yeah. So we're up to bridge number 59. Although we've tested more than 59 bridges because we tested some out of order, because we can do that. Just because it has a number doesn't mean it has to be tested in that order. And as engineers, we always learn how to be flexible when we're approaching problems. And so Ms. Summers, thank you very much. Thank you for joining us today, and we hope you enjoyed it, and we'll put these lessons to use and build some more bridges in the future. And moving over to Ethan, Isaac, Dominic, and Margot. At 0.8 pounds. And the structure there. Oh, you know what? I'm getting another comment from the testing team that we might be able to test that one on the shorter setup just to see how it goes. This one might need an adjustment. There we go. Lots of creativity in the bridges and the testing. It's a very rewarding experience. Okay, this is Addison and Roslyn. This is your bridge. And down. So we got that one came apart in the middle. So yeah, essentially. So we're gonna have a look here where it came apart. These guys here didn't have enough to bring them together side to side. So my team now is making adjustments to Buster so that we can test the bridges that came in a little bit under the stated length requirement of 50 centimeters. That's the flexibility of the design, being able to bring everything and test that. Because we don't want anyone to go away and say, oh no, my bridge didn't get tested. We want everyone to have a good time with this. All right, so we're looking for a number off of this bridge. It is number 12. Oh, so we are back to Patrick from St. Mike's. I know Mr. Ross's class had to go to another event, so hopefully they get a chance to catch this on the live stream recording later on. The block is in, the bolt is tight, bridge is resting, our display is at 0, and the crank turns again. 6, 8, 9, come on, 10 pounds, 10 pounds. I don't think so. I was hoping. I was pulling for 10 pounds. I can be optimistic on other people's work. I have to be pessimistic and add a factor of safety on my own. That's what we do as engineers. We add a factor of safety. So if you ever think of the bridges and having your cars drive across them, the bridges are designed not just for 1 or 2 on a regular day, but they're designed for a peak day and a factor of safety on top of that, so that you can have large, heavy things go across. Sometimes there are restrictions on bridges and crossings like that, and you'll see it if you keep your eyes open driving around. You will see signs that say no 3-axle trucks, or bridge weight limit of several tons. And occasionally, you know, you go the other way and you have bridges that are limited to what you can pass underneath them. But as we all know in this area, that still doesn't always get adhered to. All right, we are at bridge number 41. 1.8 for Samantha and Lily Mae. Okay. This is one of our bridges again from Amherst View. $57. All right, we're ready to go. 57 bridge. Granite. 1.8, 2 pounds. Yeah, the center portion of that. Hand it over here, please. Mm-hmm. Yeah. So this is an example. Look at these trusses in here and how much beef we've got. This section is wonderful and strong. If we take this section and keep repeating it out to the ends of the bridge, just like this, and tie it in, this is a strong portion of bridge. So we can take that. I hope you try to build another one very much the same. And this has the potential to hold a lot more weight. So good job to Brianna, Nora, and Jaden. Bridge number 59 is on the track here. Ethan, Jesse, Dominic, and Margot. We're gonna give you another check here. Starting to load. 1 pound, 2, 3, 4, 5. Hey, there we go. 8, 10, 20 pounds. Wow. Well done, 22 pounds. And we can see the difference between that bridge and the one we tested immediately prior, where that bit of truss was just extended a little more. And every time you can build that truss out a little further to hit the ends of buster and where the supports are coming, it gives us the opportunity to transmit that load. I think we are down to 58, our final bridge to test of the day. And yeah, it's getting 58. So it's even with buster adjusted, it's coming right to the limits of what we can do. So when we've got that 50 centimeter gap, it's got to be just that little bit longer. So here we go, last bridge, big finish, big finish. 5, come on, 10 pounds, 10 pounds, we can do it. 10 pounds, come on, 11, 11. Anybody else? Any more? And 10.4 pounds. So a round of applause for everybody who built a bridge this year. Way to go. Good job applying engineering and design principles as well as architecture to create bridges that look good, that test well. And I hope that you have been able to see from all of the ones that we have out here, ways that you can take your design from this year and just pump it up for next year. Because we'll be here next year. We'll be ready to do this again. And now that we hope that we're not having to do it virtually, we hope that everybody is able to come back as one group in the classroom, in the auditorium, and have a big testing event. But in the meantime, we thank you very much for participating in the physically distanced and safe way that we can test your bridges this year. Now I have someone who is going to very shortly give me the results. Oh, I'm getting a thumbs up from some results over here. So I think those are all. It's coming. It's coming. I know. I'm on edge. I'm on edge. I need my number 2. 189 2. 2. 146. 127. Oh no, those are the 200s. So for our 100 popsicle sticks and white glue, our first and strongest bridge was Azam from St. Mike's, 189.2 pounds. Second place. Yeah, it's on the first page. It's 36. So second place was Max, also from St. Michael's, with 57.8. Congratulations. And third place, 43, 36, so 43. It's a clean sweep for St. Michael's Academy, 43.6 pounds. Samantha, congratulations. And unfortunately, St. Michael's did have to log off previously, so we'll be reaching out to them with these results and let them know about their prizes. Now, for the folks who are still on, we still have 10 minutes or so. I will unmute the participants here, and if you have questions, we can take a few moments to answer some of those. So I will say, everybody can unmute. Do we have anybody left for any questions? Ms. McLaughlin, Mr. Reitzel, anything, any questions you have or that we can answer before we wrap up for the day?
What's your question?
Ms. McLaughlin.
So, can you repeat the 22 pounds one?
No, do we have a question?
Yeah.
Sorry, we're just deciding on our question.
Okay. We can probably take two if we have to, if you can't choose between a couple of options.
Can I say what?
Yeah, what's our question?
Say for the top three, like
Dominic,
the
Ethan, and
Say the top-
it's Mary Audience and Isaac, not Margot, and Jesse.
No, we're asking questions about the bridges.
Okay.
Sorry.
I'm getting a lot of folks
Yeah.
talking over each other.
I have a question.
What's your question?
What schools won? Because I couldn't really hear.
Okay. So the school with the top 3 bridges was St. Michael's. And the top bridge from that class was 189 pounds. So to put it in perspective, I am a reasonable sized grown-up man and I weigh just over 200 pounds. So I could have almost hung from that, put a hand up and swung from that bridge like monkey bars.
That's pretty awesome. We've learned quite a bit in how we can improve our bridges. So it was a great
Excellent.
experience. Thank you.
That's what we hope for every year, that people get a chance to learn something about how they can do their design and how they can do their construction. And we hope that you feel confident enough to participate again next year. Anyone else? Any other questions or comments today? No, I guess not. All right. Thank you, everyone. I will give a shout out again. Thank you to my team here at our undisclosed testing location. So it has been a pleasure to do this for everyone today, and we look forward to doing it again next year. Again, hopefully in person. Until then, everybody stay safe and keep inquiring. Thank you to National Engineering Month for helping host this event and providing us the platform to spread the news about engineering. All right, everyone. Thank you very much.